Hello everybody, welcome back to Just to Pass, and in today's video we're going to discuss on the different types of forces acting on an object. This subtopic will be divided into three separate videos. So in this video we're going to discuss on the two forces acting in a straight line. Let's say we have an object in the middle right here, and this object is being pulled forward and pulled backwards. Now the forward force is about 10 Newton and the backwards force will be 5 Newton. When we are given a force in a straight line with two directions, we will always assume one direction is positive and the other direction is negative. As a rule, we can put the positive force at the forward force and the negative force at the backwards force. Now how do we find the resultant force? What we do is we add up both forces. So we put 10 Newton plus, we don't plus 5 Newton, what we do is we plus minus 5 Newton. The reason why we plus minus 5 Newton is because we assumed that the forward direction, all forward direction will be positive and any backwards direction is negative. So the resultant force will be 5 Newton going in the direction of the bigger force here, which is the forward force. Now, not all examples will be this straightforward. Sometimes what they do is they give you an object right here and they will say a forward force of 7 Newton and another forward force of 6 Newton, and it's being pulled back with a 15 Newton force. Now, we are given three forces right here, but noted that the direction is still 2, where we have a forward and a backwards direction. So what we can do is we add up all the forces in each direction. So for the forward direction, we got 7 plus 6, and then we plus it with the backwards direction, which we assume is a negative, will be 15 Newton, minus 15 Newton. When we add up the 6 and the 7 Newton, we get 13 Newton. And 13 Newton minus 15 Newton, we get a resultant force of minus 2 Newton. The minus here indicates that it is moving backwards. And it's moving backwards with a resultant force of 2 Newton. So whenever you see a minus or a positive, it just indicates the direction. A positive would indicate it's going forward, a negative would indicate that it's going backwards. Another example of two forces acting on a straight line is when we have an object and the forces acting upon it is an upwards force and a downwards force. Now, similar to the horizontal forces, what we're going to do is we're going to assume one side is positive and another side is negative. Usually, it depends on your preference, but you just have to stick to it. If one side's positive, you cannot change it and turn it to negative suddenly. It has to just be positive. So for this example, I'm going to assume the top is the positive and the bottom is the negative. So if I'm given a top force of 20 Newton and a bottom force of 25 Newton, and we have to find the resultant force, what we do is we go 20 Newton plus minus 25 Newton. Again, the reason I put a minus 25 is because I assume that all forces going up are positive and all forces going down are negative. And what I get as a resultant force is a minus 5 Newton. This minus 5 Newton indicates that the resultant force is going at a downwards direction at 5 Newton. Another example of vertical forces acting on an object is if we have an object right here and the upwards force is 20 Newton, whereas the downward force has 5 Newton and also 15 Newton. As we can see that there are three separate forces acting on an object, but it is acting in two directions, upwards and downwards. So what we can do, if we want to find the resultant force, is assume that there are two directions and assume one direction is positive and another direction is negative. I'm going to assume that the upwards is positive, so I'll put 20 Newton plus minus, now when we have two forces acting in the same direction, what we do is we add them up together. So we have 15 plus 5, and we will get a 20 Newton minus 20 Newton, we will get 0 Newton. 0 Newton just means that it won't move anywhere and it will just stay still. So it's not moving up, it's not moving down. There's no force acting upon it. It's in equilibrium, which we will cover in another video. Now that's what you need to know for two forces acting on a straight line. We will be doing two forces acting perpendicular to each other in the next video. But in the meantime, if you have any questions, just feel free to comment down below. I'm happy to help. Until then, take care everyone.